resistance versus length lab. I am live streaming this in case you need to see this later. Um, just like you all, how can I say this politely? You have to work a lot for lab and you don't get a lot of points for it. But in the end, I think the lab work is what gets you jobs. So I also am working my butt off to get these labs done. And I'm just like, why am I working so hard for 10 measly point assignment? It's crazy. That said, I'm busting my butt just like you are, and neither one of us is getting paid what it's worth. Trust me. So I expect you guys to work hard on this for three reasons. Number one, there's more of these coming. If you do a good job today and suffer a lot today, hopefully subsequent labs won't be as bad. So I want you to learn all the little tricks, anything you got to do for formatting, and get it done right, even if it takes longer than it should, because you're going to have to do it again and again, not just at Hancock, but after you transfer too. Number two, I think it's important to look good to get a job. You have to write well and you have to format well if you want to get a job or get a raise or get a promotion. People have the stereotype about engineers and scientists that they're bad communicators. The stereotype is there for a reason. A lot of us are bad communicators. So take this opportunity to get better at communicating. And the last one is this happens to be a week when the homework assignments in the lecture aren't nearly as bad. So if you take the time to learn all these annoying little tricks, like how to use the equation editor or how to make figures or dealing with, multiple formats and programs, etc. If you take all that time to get used to that, in this week that's not so busy, hopefully that will take some of the stress off later weeks, which are going to be very busy. Okay. When we get into magnetism, it's back to getting punched in the face every quiz. Okay. So we want to get better now while the lecture homework is easy. All right. That said, what are you going to do today? I sent you all videos already. So hopefully you have those. If not, we'll deal with that after we get started. So let me get this thing under here. This button's annoying me. I'm going to fix it. All right. All right. So in this set, whoops, let me angle that down a little bit. Okay. So we're going to basically have a power supply, which is very similar to a battery. All right. So this is going to be some voltage that in the video I sweep, meaning I change it. Okay. Attached to that, there's going to be a resistor. So this is the symbol for a resistor. All right. So I'll call this R. Now, after that, there's going to be this long, skinny wire, and maybe I'll draw that in a different color just so it stands out. One, two, three, 4, 5, 6, 7, 8, 9, 10. So we basically, everybody's going to have a 10-meter long wire. So this is actually going to serve as a resistor for us as well. So I kind of made it look like a resistor there. It's supposed to be a resistor. Now, don't let the size in the picture fool you, okay? It turns out this resistor, I think, is going to be, for most of you, about 100 ohms. And this resistor is going to be somewhere in the 1 to 10 ohm range for most of you, maybe even 0.1 to 10. So this is actually, the bare wire here is going to have a very small resistance. So in the video, what I do is I just keep changing this voltage, and you see how the circuit changes. What do I measure? So in the circuit, I'm going to put 1 voltmeter here, and I'm going to call this V1. All right. And maybe I'll scoot just a little closer so you can see it better. So you can see it better. All right. And then I'm going to put another voltmeter over here. And by voltmeter, I just mean DMM, measuring voltage. Notice that the voltmeters are placed in parallel, and maybe just I'll move this over here or something. And maybe I'll label this with a wire. Okay, so the idea here, and maybe just so we could keep straight, the wire is basically going to be one of our resistors. We'll call that R2. This wire up here, I'll call R1. The idea is this battery is going to drive current through this entire system. Notice this is in series. So if you ignore the purple and the green measurement devices, this is a series circuit. We've got R1 and R2 in series with this battery. Okay, so this source voltage we could call E. Now in this case, think about this. I don't know if you could tell. This voltage is reading the voltage of the battery. This is reading that. How do you think the voltage across the wire will relate to these two voltages? Any ideas? Again, this is a series circuit.
The difference between the two?
Yes, exactly. So just like in capacitor circuits, I know that these two voltages in series add up to the equivalent. Okay, so even though we're not measuring this, I could say, ooh, this is kind of bad numbering, isn't it? I didn't think this through. Why don't we call this one voltage 1 for R1? You know what I'm saying? And why don't we call this one voltage E for the battery? My apologies. I didn't think that through. But now we don't have this confusion of having 1 on 2 and 2 and 1 and stuff. That means the voltage across number 2 is going to be voltage E, or reading E, minus voltage 1, where voltage 1 is now this one, voltage E is this one. Sorry about that bad start. Get that glare out of there. Okay, now, okay, let's see. How could I get the current in this circuit? What do you think? I want to measure the current, but I'm going to do it using these measurements already. Which one of these measurements, I only have 2, is going to help me get the current right away? Somebody other than Trey. I'll give you a hint. Ohm's law. Yeah, V over R. Okay, Alexis, thank you. So notice the current in the circuit. The current in the circuit should equal this voltage divided by this resistance, right? That's cool. So we've got V1 divided by R1. So now check this out. It seems a little circular, but this is just, I just put some DMMs on it and made the videos really fast. And this is what you got to do, all right? In the video, these are measured. In the video, these are measured. You should be able to calculate the current. And because this is in series things have the same charge. In series, things have the same current. So we've got all the current. I know the voltage across this resistor, and I know the current through it. I should be able to calculate the resistance of this wire. Now, what do I do each time? What I do is I take this lead that's connected here, and sometimes what I do is I connect it at each of these different taps. And so what will happen here is if I connect, let me put this red dot here, okay? Whoops. If I connect this at this point, I measure 10 meters of wire. If I connect it over here, I'm only getting 9 meters of wire, etc. And so what you can do is you could set up an Excel spreadsheet where you type in these numbers, right? Whatever you got, and you have it calculate these numbers, and then you have it further calculate R2, right? And then the idea is you should be very quickly able to get the resistance of 10 meters, 9 meters, 8, 7, 6, 5, 4, 1, and then you could make a plot that looks like this. Okay. We're changing the length in meters, and we're getting the resistance. Maybe it's in ohms or milliohms. I don't know which. Probably ohms. Whoops. And so hopefully we see that 10 meters has the most resistance, and there'll be some screw ups. It should look something like that question. What was that? 26.10 in the workbook or whatever. And so then the idea is you do a slope and use that slope to get the resistivity. That's the idea in today's lab. Then you write it up well. It should probably only take you 10 minutes to get the data if you know what you're doing. Since you don't know what you're doing, it'll take you 30. Okay. But I'm here to help. Now listen up. Please, please, please ask me questions and I'll help you. And then also, if you don't know the tricks to use Excel, I'll show you. I'll just be like, here, do exactly this on my screen, and then you just copy it. I would rather have you, watch. And if you want to go to Discord and copy off a friend, that's fine. But make sure you don't just cut and paste. Actually do the typing because it will stick later. Yeah. Well, it'll probably be the whole day for all of you to get the write-up done. And then the write-up is due, I forget when, Thursday or Tuesday?
Thursday. Yeah,
Thursday.
October 1st.
So now you're going to want to work quickly. So somebody might want to get started reading the handouts and stuff. I sent you a whole bunch of emails. There's so many instructions. If you're not sure which instruction to look at for which part of the lab, I mean, writing labs is crazy, right? You're expected to be good at grammar, good at formatting, good at making plots, good at making pictures, good at drawing figures. Oh my gosh. But if you haven't already done so, you should probably get an idea that this should be somewhere in your lab report. Don't do a screenshot of mine or I'll give you a 0 on the report. Again, if you just steal, you get a 0. Just draw it yourself, take a picture of it and drop it in. Or check this out, suckers. Oh my gosh, this is slow. Okay, there we go. Where is it? This is a Tinkercad version. So I made this up. So this is free if you have a Google ID. You could do make your own and learn how to do it and learn how to label it, because later on you might need this for a harder lab when I don't give you any help. Okay, so today is the day to learn these tools. If you want, right, you could do this and get out the snipping tool. Oh my gosh, did it come in? Right, do a new snip and copy this yourself. Oh, whoops. Oh man. All right, you get the idea. So you could figure that out on your own later. I'm going to stop the live stream unless there are any questions. You're either going to draw a picture like this on a piece of paper, take a photo of it and turn it in and label it and practice labeling it your own way. Or you could use Tinkercad and label it, stuff like that. Or if you know PSpice, yeah, sure, go for it. Let me see. In the video, you should learn the diameter of the wire. So I do the measurement for the wire in the video with some calipers. And I believe for most of you, just so you know, in case it's hard to read, those calipers, it's going to be 0 point something millimeters, I think, on the calipers. So it's hard to see the decimal point sometimes in a video. So just know that when you read the caliper readings, I think it's 0 point something in millimeters. The units are hard to read and the decimal point is hard to read. Good question. Others?
How many, can I ask a quick question? So how many sig figs, so when you're talking about, like, I watched the one for our group,
Yeah.
when you're saying like meters, when you're like, it's obviously this many, because you have the yardstick, how many sig figs, like,
It's a great question.
wise?
So I don't know. So let's think it through. It's probably better than to the nearest 10 centimeters. Do you agree?
Yeah.
Yeah, but probably not good to the millimeter, because if you look on these things, usually what we have to do is you have to wind it around 2 or 3 times and then go. So if I told you that when we wound these things, we went around a couple of times, how much do you think you might be off by? Estimate.
I mean, probably, if you're winding it around that, like maybe a centimeter
Seems plausible.
or
Agreed?
so. Yeah.
So do you agree it seems unlikely that we wrap this better than 1 centimeter? So now keep in mind, there's 1, 2, about 10 of those. So your total error might be, as you're winding these things, the error in the entire length might be 10 centimeters, and then 9 centimeters, 8, 7, so about 1%.
Gotcha.
Does that seem reasonable to you?
Yeah.
And this is how you figure out errors, because you need that for your error analysis if you're trying to do error bars and stuff. All right. So that's a good question. I would assume that the errors in the length are about 1%, maybe 2%, but not more than that. But not so more than 1%, sure. Less than 2%, sure. Anywhere in that 1 to 2% range seems totally reasonable to me. Good question.
And,
Others?
yeah, and when you're writing that down, it would be like when you're writing out a calculation, it would be like 1.0, because you could go, because you're certain to 1.0, and then your guess would be
So
like
what I would do, let me see. I may even have this spreadsheet might not be perfect for this lab, but this might get you started. And let me see if I have this somewhere. It's probably this one. And this is, again, not the right Excel spreadsheet because it's a little bit different, but this kind of gives you an idea. So in this particular one, if you wanted to keep track of those errors, geez, this Zoom is driving me crazy. All right, there we go. Let me get rid of this too. So the idea is, if you wanted to, you may need some extra columns down here, right? But oops. So units are not italicized. Greek letters are not italicized. If I use the symbol font, right? And so you could say right here, right? And fill it down. And if you wanted to record the errors in these, you've got it. Whoops. And that seems about right. And so, and you could keep track of your errors all the way along and make columns like this. And so if you needed this column heading, you just copy it, change it to R. The units for ohms are capital W in the symbol font, things like this. So these are what I'm saying, like the tricks. If you don't know these tricks, that's what I will help you with so that you could do this stuff faster on your own. I don't know, Travis, did I answer your question at all or not really?
Yeah, that's good. Thank you.
Yeah. All right. So if you need help with that, great. If you want to use this spreadsheet, where was it? It's probably easier to start your own spreadsheet since we're doing it completely different than what's in the old lab manual. So yeah, but there it is if you want it, ohms, and that'll at least give you a starting point. And maybe you want to take your own and model it after that last part of there. So I'll say this one last time. If you do use this spreadsheet, right? Let's see. We're basically doing this part down here. And so you would have something like this, except we're going to be doing delta L and delta R by looking at the sig figs of your measurements there. So, but I could help you with the error analysis. So we should probably get started. And this is how we should do it. You guys get the data taken. And when somebody starts getting ready to do the error analysis on the plot, talk to me and I'll live stream that. You don't have to be there, but then once that live stream is up explaining the error analysis, then we'll go from there. So the first person that gets done, come back to me and we'll talk about the error analysis, and I'll put that on YouTube for you guys to understand that. All right, let's get to it.